Oh, okie dokie. So today is the first day of dimensioning. Okay, so dimensioning, well, really what we're doing is drawing files. Okay, drawing file, the point of drawing files are like the point of blueprints. They are blueprints for 3D modeling. And just like a blueprint, the goal is communication. Okay, you've come up with an idea in your head. You've taken that idea in your head and you've modeled it in a 3D modeling software. But you can't just send a screenshot of this drawing to a client who ordered you to design something or to the factory to have them make it. They can't make it just by looking at it. You need to send them technical drawings. Okay. And the skill of technical drawing is not putting the views, which each of these is called a view, not putting the views on the screen. That's not very hard. What the skill is, it's putting the dimensions on. Okay. And our goal is simple. Our goal is to put every single dimension needed to make that part and no more. All right. So the parts we're working on, the things we're dimensioning, are not very complex. Okay. This only has like 4 part features. And even if we did over dimensioning, which we'll talk about in a second, it wouldn't get that complex. It wouldn't get that crowded with a lot of extra dimensioning. Like if we put this here and like that, yeah, it's still very clear what's going on here. It's not that hard to trace the line visually and figure out what the size of a certain part is. But the more complex the parts get, the more actual dimensions are on the screen or on the paper, because this is supposed to be, like a sheet of paper, and it can get very crowded very quickly. The more lines on the paper, the more likely there is going to be a confusion about what a particular dimension means. So that is why we have some guidelines. We could talk about standards first, which all of these or both of these slides are in the folder that's here on the calendar spreadsheet, which, by the way, I need to do some more grading of your modeling of the 3 of the green sheet parts. But these 2 slides and this quick check sheet, which we'll go over in a second, are both available. So the first one, standards, this really isn't as relevant anymore because we don't do things on paper. Now, mostly this is good for being able to appreciate how much harder it was to do on paper, because these different lines, the extension line, the dimension line, which the arrows pointing out are actually dimension lines, dimension text, arrowheads, whatever, they all have very specific standards for how big they're supposed to be. And the gap from the actual part to the beginning of the extension line, has a very specific size. And where you put the text, like if the text doesn't fit in between the extension lines because it's a small enough, the space is smaller than the actual numbers take up, you need to move it over. And all these things are done automatically for you by whatever 3D modeling software you're using, or I guess technical drawing, whatever. So there is that. All the standards are going to be taken care of, whether we are doing unidirectional text or align text, where like the actual numbers go in the direction you're dimensioning versus always horizontal on the page. The principles are the same. What matters is size and location. It's most obvious when we're talking about things with curved edges like circles or arcs, because you need to dimension the location of the center point relative to something else that's already known, and then the radius or diameter of the circle or hole. But still, the concept of size and location are the same. And a lot of these, like I said, we'll go over in better examples than saying dimension extension lines should not cross. We will have some good examples of that. We don't get into circles and arcs until later, but circles are dimensioned by their diameter and arcs by their radius. It's just one of those things that it actually does make more sense the more you think about it, but it's that trying, it's all about, like I said, communicating, which means trying to avoid confusion between you and whoever's reading it. We will pick a standard, either chain or stacked dimensioning, which is like this one, where stacked dimensioning makes more sense. There's a sort of method or mantra for making sure you get everything, and we're going to do stacked dimensioning versus chain dimensioning, but either is technically fine. And yeah, all these styles for this stuff is taken care of for you. This spreadsheet is designed for people who are doing it on paper and, drafting tables and slide rules, and way harder than it is now, which is good, I suppose. And yeah, depth signals or symbols and yeah, all this other stuff that we actually don't even get into in digitally, but you can imagine how difficult it is. So let's talk about some actual examples in the dimensioning guidelines situation. So first rule, or one of the most obvious rules, is not duplicating information. You can see here we have this dimension of 2 is the total width of the object. The distance from the left side to the right side is 2, and it's here on the front view, which is good, but it's also here on the top view. And that's this, it's not just the same number, it's literally dimensioning the same thing. So it's redundant. We don't need it. Same thing for all these. This and this are not just the same number, they're both measuring the distance from the left edge of the object to where it jumps up again, which apparently is 0.75. Okay, we don't need it both places. And so on. This is measuring the depth, looking at it from the right, and this is the depth looking at it from the top, which that's another thing I just jumped by. This view is the front view. This is the top view. And this is called the right side view. You won't always have these 3 views, but it's a pretty standard situation, especially since in our green sheet, we can see a top, front, right isometric, which that is this 4th view we are going to make, and it is going to be an isometric view, which there's a lot of double use of words, like the dimension from the left side to here is 0.75. So we need to dimension it by putting a dimension in that location. So just realize that there might be some multi-use of the same words. Like this is the top view, meaning viewing it from the top, but this entire drawing is called a view. It's the top view. This is the front view. This is the isometric view, or projection. And don't worry about what projection means at this point. Okay, so over dimensioning, bad. Okay, it's all under that theme of communicating, but not miscommunicating. So this is bad. We don't need these redundant things. We will explain, well, okay. So you could have this one or this one, but not both. But we have a tendency to do dimensions on the front view. What makes a good front view is something that gives a lot of information about the shape. This front view, you can tell this particular shape has this contour. Contour meaning the edge of the shape. When you're looking at it from the top, all you can see is that it's a rectangle. We do not have very much information on this particular shape looking at it straight down. Now, you can only see two dimensions, height and width, height and depth, or width and depth from any one of these views, but you have a much better idea of what's going on from the front view than the top view, and so most of the dimensions will be there. Okay, specifically in something like this 0.75, the distance from the left to this first edge is 0.75, and yes, technically this one is correct, but if we put it here, we know it's the distance from the left edge to where it turns up at a 90-degree angle. And it turns up that much just by looking at it. So what makes a good front view is something that has a lot of contours, and that also contours are where we want to dimension. More on that in a second. Okay, so that is the correct for that one. Okay, this is another example of over-dimensioning. If we know the distance, the total width, which we will always have total width, total height, and total depth. That is always a dimension needed. If we have total width as 2, and we also know the distance from here to here is 0.75, and the distance from here to here is 0.75, we can math that out, this minus this minus this, to know that the remainder is 0.5. We don't need this, or I should say your client or the factory that's building it doesn't need this dimension because they have they can figure it out. It is implied. And the same thing for here. If we know the total height is 1 and we know the height to this ledge is 0.5, we know the remainder is 0.5. Now, again, these are really simple shapes. This one is done with like 8 dimensions or 6 different dimensions. Adding 2 doesn't really make it more likely to be confusing, but we're learning rules that work for more complicated things. Okay, so we get rid of those things. All right, like I said before, drawing to a contour. This is exactly what I was talking about before, where the distance from the left side to this first edge, on the top view, we have no idea what's happening there. All we know is that there's an edge there, which is like that edge. But from the front, we know that distance is the distance from the side to where it jumps up a little bit at a 90-degree angle. So this one makes more sense here. Same thing with this one, makes more sense here. Total width is always going to be to a contour, but it's going to look a lot better if they're all on the same view. Okay, total width is always going to go to the edge of, you know, where the shape changes direction. It has to, but they tend to look better on the front view, which is our main view. Okay, so we haven't really looked at hidden lines before, but if you were looking at this particular shape from the right side and you had X-ray vision, you could see this edge right here. Okay, this surface, looking at it from the right, if it like jumped through, you would see a line right there. That makes it a hidden line. In our technical drawings, hidden lines are dashed lines. Okay, we're communicating that when you look at it, when we draw a hidden line, it's drawn as a dashed line. Okay, that communicates that there's an edge at this height, but it's not an edge you can see from this particular view. Now, the place to put this is where it actually looks like a contour. Hidden line is not likely to be the best contour. So you put it over here. We do generally like dimensions to be between views, meaning like, but in this area of the page or this area of the page, as opposed to outside, outside, or outside, or outside. Just generally on the screen, we want them between, but if it's going to break one of the other rules, like going to a hidden line, we don't like it there. Okay? The reason we like it between is because if you're looking at something complex on the top view, you can just, your eyes only have to move this far on the page to see, you know, its relevant dimension. Where if all these dimensions were on the other side and like that, you're crossing over visually, you're crossing over a lot more information. And again, you know, communication or miscommunication type of thing. Okay. Again, lines crossing only increase confusion. We do not put things on top of the drawing. Occasionally, extension lines will need to cross over the drawing, but we're not putting actual text or numbers on the view. That's a no. And we don't do extension lines to other views, even if this is technically pointing to the same thing as if it was pointing down here or extending from there. But we don't do that. And actually in Onshape, it doesn't even let you do that. So that's good. Okay, between adjacent views, but whenever possible, meaning this is lower on our what I call hierarchy of sins. I don't know, it's not an official term. I mean, it's sort of tongue in cheek. But like I said before, generally we want to look for places in this area and this area of the screen. And I suppose generally this area and this area, because these are the same. But we'll move on with that. Okay, we don't want extension lines to cross if possible. Okay, we would look for somewhere on the right side view to avoid this. And yeah, crossing extension lines whenever possible. Now, this is an obvious one because there's a better place to put it where the extension line doesn't go over the view. But this is in that category of not always possible. Circles are dimensioned by diameter, arcs by their radius. And you put that where it looks like a circle or an arc, as opposed to like here, which this distance is actually the diameter of the circle, but it doesn't look like a circle there. That is not where it is a circle on the page. So you put the dimension there. And there's a lot more with circles and arcs, holes, that sort of thing, which we'll get to later on. Still size and dimension, or size and location, crossing extension lines, and I think the rest of these are just circles, curved surfaces. Yeah. All right. So like I said before, the hierarchy of sins, so to speak, meaning the worst one versus the least worst one, least bad one. You don't want dimensioning on top of your view. You don't want extension lines crossing. But if you had to choose between dimensioning on top of the view and having your extension lines cross, you'd rather have your extension lines cross. Okay. And dimensioning to hidden line / non-contour going to, which I could probably think of a better way of phrasing that, is worse than having your extension lines go onto the drawing, onto the view. And not between adjacent views is just one of those things that we'd like to do, but if it breaks any one of the other rules, it's fine. And I mean, if it breaks, if going between adjacent views prevents you from breaking one of the other rules, not going between adjacent views is fine. Don't over dimension, and just some general situation. If you didn't need the dimension when you built or modeled the part, you don't need it on the drawing. And when we get through, we do chain dimension, or excuse me, stack dimensioning. Start on the left. Every time something happens, take a dimension, then check if it could be in a better place, and also keep things neat. All right, so let's go ahead and jump right in. You can go to your green sheet letters document. And if you were in here last semester and have all different documents for the parts, it's fine. I mean, it's going to be a little clunkier to grade, but you need to go wherever you have the particular part we're working on, which we're going to start with part C. So go to wherever your part C is, and we are going to create instead of a new part studio, create a drawing. Okay, and the standard is fine. Go ahead and do this. We're all doing this. If you have a question, you can raise your hand. I'm happy to stop right now. And so we can actually start by introducing the drawing that I want, which why can't I just see everything at the same time? So part C for me is now been introduced, and let me zoom in. There's a few other things we need to change before, but when you choose that part, the view you're getting is the front view from when we made it. Now, if you don't want this to be the front view, you can change it at this point and have the top view from when we made it be this front view on our drawing, because nothing is really set in stone. But for the most part, the drawings we made in the part files, their front view is going to be the best front view. Okay, so we go ahead and set it down here. We can adjust size and location of the actual views in a second. You'll notice that this button is already selected. This is project view, and we are projecting the front view. We're going to project a top view. So you click again. Then if we still have, okay, so we still have projected view. We want to click again on the front view and project a right side view. And then we want to click on the front view and project our top right front isometric view. And then we are done with this drawing. You can hit escape. I don't know why right click escape doesn't work, but we need to get rid of this tool. Okay, so now's a good time to reshape it or space things out. I'd like to have a different standard. This is a little big for what we need. Okay, we'll worry about that later. Okay, you'll notice that if you click and drag this around, the relative views line up. That is another principle of technical drawings. This top view has to be directly above the front view so that everything lines up. That helps communicate different dimensions. Okay, and this top front right isometric, we're going to go ahead and click on that, regular click, and go to, wait, hold on. Can we just do it here? Right click, show hide. I want shaded show. Oh, show shaded view. What's up? you go to, okay, I guess I can't. You go to click on, well, you probably still have projected view up, but if you lost it, click on that. Then click on the front view again, right side, and click on, well, click on the front view and then top right. So you got to go back to the front view because that you're telling it's projected based on that. And then you're done with it. So can you click? I guess you could click on it again to turn it off. But I really don't know. Like every other tool in this, I almost said game, every other tool in part files, you hit escape and it cancels it. Or you can do right click to escape, but not in drawing files. Okay, so this is going to be our base format for everything we do. Front view down here, top view, right view, and top right view. First thing we can do is right click on this, our isometric view, and go to show hide and show shaded view. Okay, that's where you can see, well, I mean, you can see it's full color. Whatever color it is in here will switch over. Let me see if it switches over immediately. And if we go to that, let's see if it switches immediately. And I'm guessing that's a refresh. Come on, don't prove me wrong. Yeah, okay. So you can see whatever you do in this will get carried over. Color and design and anything else. Okay, so this is our isometric view. You don't really worry about why it's isometric yet. But it's sort of like our picture, just to give the user, the reader, the audience, some general idea, a good general idea of what they're looking at. And so now we just need to worry about dimensioning. So like I said before, in that one of those mantras is start on the left, and every time something happens, take a dimension. Then we'll start on the bottom, go up, and every time something happens, take a dimension. And then start on in the depth, start on the front, and every time something happens, to take a dimension. So because this is our front view, our width is going to be going this way, our height is going this way, and our depth is either here or here, depending on what works better. And we'll do things in that order. Doesn't technically have to be in that order, but I'm giving you a method that works, and we'll stick with that. Okay, so the term something happens is where some line, edge, point, something exists. And we're going to measure everything from the left side. The first thing that happens is this line right here. And this is just like dimensioning. The click process is just like dimensioning, making a part, except you can't change the size here. This is just about communicating the size, where in a part file, it's about constraining and changing the size. But the clicking, the difference, but we want to know this length right here. So our first click's going to be there, and our second click's going to be there, and move up to set it. There you go. You notice that we have a nice, attractive gap for the extension line. The arrows and everything are all good. We are going to mess around with text size because it's going to get a little big, especially we don't need 3 trailing zeros. I mean, degree of accuracy is great, but we don't really need that. In fact, what is it? Does that change something? Yeah, I guess we could change it there. But we want to do changes that change for the entire document to be consistent. Okay, so moving, now we've done something, so we go back to the left and work our way right. The next thing that happens is this edge, which is this edge right here. And we could technically put it the distance between here and here. But there's actually a better place to put it. And the better place to put it is between here and here. And the reason why it's a better place to put it on the top view is because we're dimensioning from the left side to a contour, where on the front view, we're dimensioning just to a line. All we know is it's an edge. So we're going to keep only the one that's on the top view. Okay, and we'll space things out nice and neat. And going back to the left side, the only other thing that happens is the total width. That's the last edge that happens. So we can go ahead and dimension all the way across the distance from there to there. And that's it for width dimensions. Now, height dimensions, we actually need to turn on hidden lines. I wish there was a universal button for hidden lines. Whatever, it's not in there. I'm pretty sure if you right click, you can show hide hidden lines, and I wonder it's going to work for all of them. Ooh, okay, what if we shift, select them all, show hide hidden lines? Really? Is it because I already had it on the first one? Show hide hidden lines. There we go. Okay, so the only hidden line for this one is this. And God, I can't believe that there isn't a show hidden lines universal thing. I've got to find that. But anyway, the way that I did that, and until I think of a better way, it's the way it's going to work forever, is click on the first one so that it's selected, hold down shift and click on all of them so that they're all selected, and then right click anywhere and do show hidden lines. That way you don't even have to check whether a view has hidden lines. So of this part, or of our three views, the only hidden line is this one right here, which is right here on the isometric view, which is saying this edge right here. Now, there would be another one, sort of this back here, that makes that shape, would show up as a hidden line here or here, but it's covered up by a solid line, and you don't have to worry about the fact, but if you were doing it on paper, you would know that a solid line covers up a hidden line. It just does. But here, this one hidden line matters now because we need to dimension our height. Now, there's a few places we could put it, and I'll show you all the options. First option that we normally look for is between adjacent views on the front view, which would be the distance to here. And we would like to avoid having our dimension lines go over the view. So look over here, and it will let us dimension to this hidden line. But again, we don't like hidden lines. So our best option is actually just this. Okay, it's outside of adjacent views, which isn't good, but it is better than the other option. So then we go back down to the bottom and work our way up. The next thing that happens, the only other thing that happens, is total height. And you can usually put total height, total width, total depth anywhere, because it's always going to go to a contour, but we like the front view. And there you go. That is the height, all of the height dimensions. So next and finally, we only have depth, which either has to go here or here, because you can only see depth on the front view or the right view. You can't see any depth from the front view. And so the first thing happening from the front back is this edge right here. which looks like this on the top view and looks like this on the right side view, we definitely want to put it on the top view for this particular shape because it will dimension to a contour, where here it just dimensions to a straight line. So we can dimension the distance from the front to here, and that handles that. And then the only other dimension is total depth, which can go here. That would be fine. Or it can go here, also fine. I'm going to say there's a slight tendency to go here just because there's already this one here. But as long as you only have it in one of the places, it's fine. And there you go. That's part C. Let's make sure to rename, right click, rename. Let's just call it drawing C to keep things organized. And I'm going to put a space in here. Okay, and if you think about the way we made this, the first thing we did, if you recall, and you could probably think about it just because we made so many, we made a rectangle, total height, total width, total depth. We have that dimension, we extruded it, that dimension. Okay, we needed all of those. Then the next thing we did was make this rectangle, this like 4x3, which is this height we know from this, and this height we know from this, and the extrusion depth is 2. We don't need this depth because we know they line up here. And the only other dimension was the only other feature was this cutout, which we have from here, and this gives us this, and then the total height, which we know from here. Now, this, I'm just hearing myself explain how you can work through and check. I realize that's more complicated. If you stick to the process, you trust the process, you'll be fine. The left or the width left to right, height down to up, and depth front to back, you'll be fine. And let's just neaten things up. The dream is to have your actual text like in the middle of your arrows and things nicely spaced. If you can, you don't want things like overlapping or too crowded. And let's see if we can fix a few things just format wise. Let's go to, all right, so well, we'll worry about it when it gets crowded, but something we will do in the future is over here on the right, the settings, the wrench settings, drawing properties, go to the dimensioning properties, and we're going to change the text size from 0.12 to 0.1. Here, it's not a big deal because it we don't have a bunch of things on here, but it will be useful later. And length precision, we can just go to 2 decimals or even 1 or 0 decimals, since everything we have is a no, not chamfer dimensions. We just want regular dimensions. Dimensions, underline, dimension, length precision. No, not chamfer dimensions. What about annotations? DM size geometry. I'll find it. I found it yesterday. No, it's not this. It would be something. Oh, yeah, we can probably turn off trailing zeros. I don't know. It doesn't really matter at this point. It's not super crowded. All right, so the next one we're going to do is part I, because it is a different style. And then we're just going to tear through these. And it's going to be kind of slow at the beginning, just like modeling them. But by the end, it's going to take you about 10 to 15 seconds to do something like this. So we need to make a new drawing. Create drawing. Feel free to play along for those of us who are just playing on their phones. And so we have a new drawing. It came up right here. Just so you can figure out which one you're working on. It will ask us which part we want to start with. There we go. We want part I. And we'll give it a good front view. And it gives us the projected view tool, top view, still have the tool, got to go back to the front, right side, and back to the front and top right. And we can turn that off. Before we forget, let's go ahead and rename the drawing. Drawing I. And just our basic setup, let's do right click on this one and do show hide shaded view. That gives us our picture. And then we will turn on hidden lines. This one doesn't have hidden lines, but I want to get in the habit until I can find a better one. Click on the first one, hold down shift, click on the other ones, and right click, show hide hidden lines. And like I said, there aren't any on this drawing, but oh, that's not what I did. That's not what I want. Show hide shaded view. Show hidden lines. Okay. Very disappointed I can't thickness, show viewing planes, flat break views, instruction geometry, extended lines. We like that. I will find it. It's got to be in there somewhere. All right. So if you recall the way that we made this one, we only needed a few dimensions to make this. We started out with the height, and we did this all in a single drawing. We drew a line, whatever height this is. We drew a line, whatever width this is. Drew this line, whatever width that is, and then connected these points. Well, there's this line here, but we connected these points. If you recall, we never needed to dimension the length of this line because we knew where the line started and where it ended. Okay, that means because we didn't need it when we made it, we don't need it when in the technical drawing. Okay, this would be considered a redundant one. All we need, I can't believe undo doesn't get rid of anything. All we need are the things we needed when we made it, which are, like I just showed you, this dimension, this dimension, this dimension, this dimension, and the depth extrusion. Okay, so we don't really need to go through it the way we made it. We can go through our mantra. Start on the left. Every time something happens, take a dimension. The first thing that happens is the distance between here and here. Okay, this dimension, this edge could go on the top view or the front view. It's the distance from here, which is the distance to here. But on the front view, you can see that it's where the plane's going, horizontal plane goes to a sloped face, where on the top view, you can't see anything, what's going on. So we're just going to keep the one on the front view. And the only other width dimension is total width. So we can put that here or on the top view. It doesn't really matter. And so that's it for width. Height, going down to up, the first thing that happens is this, which, like the other one, it could go here, but on the right side, it doesn't go to any contour. So we'll keep it on the one on the front view. And the only other height is total height. And usually, like I said, keeping things to the front view. But here we have extension lines crossing, which is not what we're looking for. So we are going to not have it here. We're just going to have it here. And that's it for height. And for depth, starting front to back, the only thing that happens is total depth. So it could go here or here, but not both places. And that's it for part I. Everything we needed to make it, nothing else. Clean, nothing crosses over. There aren't any hidden lines. This is a very basic shape to do. And very basic shape to do, but that's fine for us right now. Okay, let's go back and we'll tear through a couple more. Our pacing is probably going to be similar to when we made them, doing like 4 or 5 or 6 a day, not a ton of them, but we'll just go through them in order. Okay, next one is going to be part A, and let's go ahead and create a drawing. It puts it right there. We want, what happens if we just automatically do 4 views? It's not letting us. No, that's fine. Okay, so basic template. And it puts it right there. It's called drawing 1 right now. And let's wait for it to work through. Okay, and let's choose from our options, which under part A, I guess it's called part 1, from inside of that for me. And so let's go ahead and set our first view. And we already have projected view. Let's do top view. And go back to the front view, right side view. And back to the front view, top right isometric. And we could turn that off. And then our basic setup, right click, show hide, shaded view for the top right. And then for the rest, click it goes to what? This view right here is upside down. Does your front view look like that? Does your top view look like that? Does your right side view look like that? And this looks different. Are you, when you make this, are you clicking on this one and then going up, right? Okay. I'll help you in a minute. It's not mission critical at this point. And all right, so for our isometric, we'll do right click, show hide, shaded view. And then for the other ones, we'll do our click, hold down shift, click and click, right click, show hidden lines. And this one does have a couple hidden lines. And it is not common, I don't want to say ironic, but not common to have a lot of hidden lines on the front view, because hidden lines tend to be where contours aren't shown. And so our front view is usually going to be a view, a direction of looking at our part that shows the most contour. This is an exception, I would say. I think the defining characteristic of this part is that it's an L shape with some other stuff. The top view makes it look like sort of a C shape, you know, or like a magnet shape or something. And the right side view makes it look like, I don't know, something with horns or a cartoon with like eyes or whatever. But I think the defining shape is that it's an L, which is why it still works out as the best front view. Okay, so jumping right in, starting left to right, the first thing that happens is this edge right here, which meets all the rules between adjacent views, doesn't cross over anything, goes to a contour, you know, could go up here, but that's not as good because this isn't a contour. It's like an interior line. And that's it for that one. Okay. Going back to the left, the next thing that happens is this hidden line right there. And it's a hidden line. So let's look where else we could go. And the other place we could go is right here. And this one is not ideal, but I think we still want to avoid going to hidden lines because that's not what I meant to do. Because the other one still goes to a contour. The line just crosses over, the extension line just crosses over. That one is it's a not great situation either way, but I'm going to stick with that. And then the only other width is total width, which can go here on the front view or the top view. It's all total width, height, and depth will always be to a contour. So we're good. Okay, so now depth down to up. First thing that happens is this ledge right here, which is ideal. It's a contour, nothing crosses over, no hidden lines, perfect. And then down to up, the next thing that happens is that hidden line, which causes us to cross over extension lines, which is not good. If we really were in love with this position, we could switch the total width to there. And then we wouldn't have a crossing extension line, but we still don't like it because it goes to a hidden line. So we don't want to, like, you know, fight for it. So we'll go ahead and do that same thing we did here from the bottom to here as the height of where this happens. And the only other height is total height, which is here to here. Again, crossing over extension lines. We could, like I said, switch the total width to the top view. But even if we did that, we still have this super long extension line, which is not ideal. So let's go ahead and do total height over here. That's nice and neat. And then we just have to worry about depth. The first thing that happens going front to back is the location of this, which is definitely not good. It can go right here and meet all of our rules. So hit escape, and I think that probably makes more sense outside of the extension lines. Maybe if we switch back to edit like precision as like 2 decimals or no decimals, that would be good, but don't worry about that. Just generally just making things neat is what we're looking for here. Okay, so we don't need this one. And the next thing that happens front to back is this, which this is definitely where this goes. Contour, nothing crossing over. We're good. Next thing that happens is where the other leg goes. And now I want to space things out a little bit, which is fine. Everything comes with you. The next thing that happens is the other side of this. So front to back, which in order to understand what's going on, you have to understand that that this is the front and this is the back, and that we're looking at it right that direction. Okay, and that this is the front and this is the back, looking at it from the top. Okay, so the next thing that happens is this location here, which we dimension to the front, contour everything. And the only other dimension is total depth, which we could put here. And technically that'd be fine, but it's starting to get crowded with where our drawings are. Yes, they move, but I think it works a little better up here. And as long as you don't have it both places, it's fine. Done. Let's go ahead and name it. Rename drawing A. And what time are we? Let's do one more and then we'll have A, B, C, and I done at this point. So looking at B, this is what B looks like. Let's do a new drawing and hit OK. Okay, you don't have to be looking at the part you're doing a drawing of, but it puts the drawing right next to it on the screen in the tab right next to it. And the part we want to put in is part B, which is still, it's called part 1 in that file, but that's fine. Okay, front view, top view, front view, right side, and front view, top right. Turn that off. Right click on this, show hide shaded view. And then click on this one, hold down shift, click everywhere else, right click, show hide hidden lines. And this one does have a couple hidden lines. And there we go. Okay, so right away we have a interesting conundrum or a not ideal situation. The first thing that happens left to right is that distance right there, which that's actually weird. It's drawing the distance on the sheet, not the real thing, because we know that's an inch. So either way, it's the distance to where this ledge starts. So the places we could put it in our normal place would be on the front view right there, but not ideal, and not just because of the number of characters there. Another place we could put it is on the top view, but that's going to a hidden line, also not ideal. So the best place for this is actually down here, outside of adjacent views, because we get to go to a contour and we don't have to cross up anything. Okay, an awkward start, but here we are. The next thing that happens is the distance from the left side to the top of this, the top of the top. Okay, next thing that happens working left to right is this point right here. Easy. The other side, the next thing that happens is the other ledge here, which we have the same issue. Hidden line, crossing over, or outside, which for outside, we haven't done one yet, but we're starting to get a lot of outside stuff, and it actually might look better to do, instead of doing the distance from the left, you can do the distance from the right, which is that. And that actually, I think just the symmetry and balance of it probably makes it look a little bit better. But, you know, you could have the distance from the left side to this point or the right side to that same point, but just not both places. And I just figured out that if you hit escape or get out of the dimension tool, it will let you do an undo. So that's good. And then the only other width is total width, all the way left to all the way right. There you go. Okay, height down to up. This one's actually kind of tricky because the first thing that happens is this ledge. And we're already getting kind of crowded. It makes me want to do to find the precision units primary. Oh yeah, there we go. Okay, so not a bad idea at this point. Go to the wrench, go to the first tab up here, units and precision, and change precision to 0 or no decimal. That'll give you some more space. Okay, so we need to figure out the height of this ledge, which we can do here. It's crossing some, the extension line's crossing over. Not good. We could do here, but that's a hidden line, also not ideal. We can do it in here. Okay, we can get rid of the ones we don't need at this point. Sure, this one, and this one, and rearrange this one. And it's a little awkward to have it like sort of inside of the space, but the options we have are limited. So I would say either this or this is fine. Now, if you'd have to rearrange in order to get it all in there. But I don't know. It's sort of a crowded situation regardless. I'd say probably that looks the best. Either that or inside. The problem with inside is your dimension arrow is now on top of the view because it's such a tiny view. So not ideal. I wouldn't hold that against you if you put it the other place. Okay, height going down to up. The next thing that happens is this ledge, which here we go, attached to the front view is fine. And going up, the only other height is total height, which looks like that. Not ideal, crosses extension line. So let's just put it on the right side view. Get rid of this and dimension total height. There you go. And then that's it for height. The only depth is front to back, total depth, which can go either top view or right side view. Just because of the shape of the paper and where the isometric is, I think I probably have a tendency to go top view instead of right side view, but it truly doesn't matter on that one. And so we found the precision situation. But I'd like for there to be a way to do all of, like, have a complete like system property, but we'll worry about that later. Okay, so at this point you should have drawings A, B. Let's go ahead and rename this one. Rename drawing B. Okay, drawing, well, all the letters, because we did those a while ago. And drawings A, B, C, and I. And that's going to be it for today. I'll post the video as soon as it's done processing. If you're having technical issues or like something's not working for this, come see me. If you are done with any of the parts that we've already done, any of the green sheet parts, the letters 1 through 10 or 11 through 20, and don't have a grade for it, you can come see me right now and we'll do a grade. Okay, that's it.